Probability distributions are amazing things. Recognizing their existence allowed us to detect patterns. Applying probability to logic allows us to weight our assertions by their evidence and likelihood. When you think about discrete events, it's easy to understand probability. There is an event A, and it either occurs or it does not occur. Given the state of A, event B has a set of conditional probabilities for whether it will occur or not. With discrete variables, a probability of 0 can exist. That is, what we know about the probability of discrete events allows us to reason about impossible events. But probability is quite different for continuous variables. To even think about probability for continuous variables, you have to assume that the variable exists. That is, the area under the curve of a continuous probability distribution equals 1. This means, across all possible values, the variable ultimately exists. We cannot consider the probability of a continuous variable without first assuming the variable is possible. But assigning a probability to any exact point is difficult. In fact, the absolute probability of any specific point or value of a continuous variable is 0. Many continuous variables extend out infinitely, but all continuous variables extend in infinitely. So with an infinite set of possible values, the expectation for any particular point is 0. This means we can only calculate probabilities for intervals of values of continuous variables. That is, instead of finding the probability that a continuous variable will equal 7.0, you find the probability that the value will be between 6.99 and 7.01. The last thought I would like to leave you with is that this applies to probability itself. The beta distribution is the distribution of probability. It is continuous, ranging between 0 and 1. One thing this means is that probability exists. The area under the curve of the beta distribution equals 1. Probability has to exist. It is impossible for it not to exist. While, like at the time of the singularity before the Big Bang, all outcomes may have had a probability of 1. But there is no universe in the absence of probability. Yet, the absolute probability of any exact probability is 0. The probability of a probability can only be calculated for an interval of probabilities. Let's think about this for a while paying attention to your breath, the sounds, the visuals, or some combination of these things. Thank you for joining me for this meditation.